Hey, welcome again. So in this video, we're going to talk about the law of conservation of linear momentum. Again, if you don't know what momentum is, make sure you watch my previous video on Newton's second law of motion. But simply, I can tell you momentum is like the quantity of motion or the strength of motion. How strong is a certain motion? For instance, again, I am giving another example. If maybe a bus and a bicycle, they're both moving at the same speed, which one do you think will have more strong, which motion is stronger than the other? Of course the bus, because it has higher momentum due to its large mass, right? So now let's see how this strength of motion, it has some laws governing it when maybe it occurs a certain collision or something like that impacts. So we come to the law of conservation of linear momentum. It states that when no net force acts on a system, the total momentum before collision equals to the total momentum after collision. Simply, momentum is conserved, that the law states that the conservation of linear momentum, it's conserved if and only if no net force acts on the system, right? So the total momentum before collision is normally equal to the total momentum after collision. Now this law is too obvious if you try to think of it. It's very obvious. I wonder where my grandparents were when Newton was discovering these laws. Perhaps we could have been more famous family like how Newton is. You see, why am I saying it's obvious? So imagine maybe in a car crash, right? No, that is a negative assumption. Let's say pool table. If you've ever seen that those balls, you see, kick them, they move and things like those. You see? So you have maybe this ball and this ball, right? Maybe one is at rest, the white ball is coming and kicking it, right? Now I want you to visualize it in your head. That white ball is having a certain speed, right? It's moving to go and kick this ball which is at rest. When they collide, this one has momentum, right? It has mass and it has some velocity. When it collides, it will transfer some of its momentum to this one, right? Why am I using that transfer some of its momentum to this one? Because momentum is always conserved. Momentum doesn't come like from somewhere externally. No, momentum is constant. The momentum which this thing was having, it will give some of its momentum to this ball, right? So that means this ball will then move to this direction, like this momentum. Remember, momentum is a vector quantity. I want you to know that momentum, so direction when matters, momentum is a vector quantity. That means its direction matters. So the quantity of motion mass times velocity. So this one has a certain mass moving at this direction, this velocity. So it will give its momentum, some of its momentum to this ball here. So the ball will gain some momentum and it will move to that direction at a certain velocity. And this one, its velocity will decrease, giving it some of its momentum to that one. So I want you to assume momentum like something which is enclosed in the system, not conserved. Like we have certain objects moving, having certain momentum, then that momentum is always conserved. Maybe this body will give some of its momentum to this one will receive some of its momentum to the other body, like that one. So this one had some momentum, it gave some of its momentum, some of its speed to this one moved in this direction. The momentum of this one, you will see it will decrease its speed, or sometimes it will stop. If this one stops, that means it has given all of its momentum to this one. The concept is that momentum is always conserved. The total momentum before collision equals to the total momentum after collision. That is what I want you to understand before we go to solving questions. Make sure you understand that momentum before equals to the momentum after. If you understand this law, any question will be easy for you to solve. And make sure you watch my next video where I'll solve some questions. But all I want you to do is to understand and be able to tackle any question. Don't end up only on the videos in YouTube. Make sure you find a book, solve for yourself, try to read more and more and understand this concept. Thank you very much. Make sure you subscribe to my channel and watch the next video on solving this linear momentum.